Hi everyone, my name is Junyi, and today I will make a presentation on work summary of assignment 2 of ENGG955. So the assignment 2 is a continuation of assignment 1, and it contains an abstract, an introduction, a literature review, a research design, a research question, some references, and literature planner. So here comes to the research topic. The broader one is robotic wire arc additive manufacturing process for hollow turbine blade, and I choose a more specific one, which is the multi-sensor monitoring system in WAM process. So there are 3 objects that need to be monitored in the WAM process, which is the weld pool, weld bead, and weld arc. So why I choose this topic? Because the WAM process can provide us as suited to manufacturing large-scale metal parts, for example, the hollow turbine blade, and within the multi-sensor monitoring system, it can product components with a high-level automation, consistent mechanical structure, and a high geometry accuracy. So here comes to the literature review. The first object is the weld pool, and there are 2 parameters that need to be measured. The first one is the size, and the second one is the temperature. So Sean just applied a charged coupled device camera to measure the size of the weld pool, and to improve this one, the Lu just used 3 reflecting mirrors and filters plus a CCD camera to measure the size of weld pool. As you can see from these figures, the 3 filters is here, and with some mirrors, and the 3 different locations of the weld pool can be measured within a CCD camera at the same time. And also at the same time, and Craggers provide a high-speed near-infrared CMOS camera and a prototype to measure the size of weld pool. And also, the temperature can be measured more easily. Just use a parameter connected with a CCD camera. You can just measure the temperature of weld pool. So the next is the weld bead. So as you can see from this figure, there are 3 parameters that need to be measured. The first one is the width of the weld bead and the reinforcement, which is from the top of the bead to the substrate. And the final one is the penetration, or so-called the depth of the bead. And to measure the width and the reinforcement, the Pinto used a CMOS camera, and Chen used a line-structured light measurement method. And however, because the penetration cannot be measured directly, so Evelus just developed an evaluation system to predict the penetration of the bead according to the information about the width and reinforcement. And the final one is the weld arc, and there are many parameters can be determined by the arc sound, as the flow rate, arc length, welding speed, and welding current. So the measure of the arc sound is much more easier. So just use a microphone, you can just capture the arc sound, but at the same time, the arc sound will contain other noises, like the machine's noise, and this can be avoided by the pre-filter. And so here is the research question. We all know from the literature review, the monitoring system is crucial because you can monitoring the process and get some information and use this information to adjust the next welding parameters. But however, none of these researchers focus on the whole system. What I mean is the literature review just focus on one object. So why not we just integrate various objects together to establish a multi-sensor system, so you can monitoring the whole WAN process at the same time. And here comes the framework of my research design, a multi-sensor system framework. And you can see there are 5 layers: the sensor layer, signal layer, feature layer, decision-making layer, and the output layer. For the sensor layer, there are multi-sensors. There are multiple sensors to measure different parameters of the WAN process, like the infrared thermal sensors is to measure the temperature of node pool. And because of the raw signals cannot be used directly, and so the signal processing and methods are used to extract effective information from the raw signals. And for this, for the effective signals, their corresponding parameters will be determined in the feature layer, like the arc current. It is determined to the melt pool condition. And after all the parameters obtained from the previous welding, and the computer in the decision-making layer will optimize all these parameters and use them to do the next welding. So the output layer means the next welding. And here is some strengths of my research design. The first one is it can provide a fully automated WAN process. And secondly, it can provide high geometry accuracy components. So there are also some limitations of my research design. The first one is weld bead measurement is not real time. So by measuring the weld bead, you can just measure it after each welding process. It cannot be measured during the welding simultaneously. So the second one is the signal processing algorithm can be improved. So there are many other methods to process the signals more effectively, and this can be improved by future works. Thank you so much.